In the US, we use different measurements than most countries. Instead of using milliliters, we use cups, teaspoons, and tablespoons. We originally have 2.5 cups of flour. That is 312.5 milliliters of flour. We also have 2.5 cups of buttermilk. That is also 312.5 milliliters. We have 1 teaspoon of salt. That is 5 milliliters. We also have 1 teaspoon of baking powder, which is also 5 milliliters. We only have 3/4 of a teaspoon of baking soda, which is 3.475 milliliters. Next we add hot water. We have 1 tablespoon of hot water, so it's 15 milliliters. Finally, we have brown sugar, and that is 2 tablespoons or 30 milliliters. Last we add eggs, but since eggs just come in one measurement, we don't have to convert them. Unit conversions are important because other scientists need to be able to replicate your experiment.
One of the key ingredients in buttermilk pancakes is the buttermilk. Today I'm going to teach you about how cool it is and how you can make it at home. Buttermilk originated on the homestead when nothing went to waste. This included the leftover liquid after churning butter. When this liquid was mixed with the natural airborne bacteria, it thickened and soured as the lactic acid producing bacteria in the milk fermented it. The result was the tangy liquid we know as buttermilk. People quickly realized that buttermilk made an excellent addition to baked goods. Buttermilk is actually quite easy to make at home. The kind of buttermilk you can make at home isn't actually buttermilk, though. It's milk that's sour, using plain milk with the addition of an acid, such as lemon or vinegar. Real buttermilk is made through a long fermentation process, but this method produces the same flavor and has the same effects on the baked goods. When making buttermilk at home, the first thing to understand is that plain milk is actually made up of a lot of different components. The big ones are fat, water, and protein. When you want milk to curdle, the component you're dealing with is mainly the protein called casein. Usually little missiles or groups of casein float around in the milk without bonding to anything. These groups of casein are negatively charged, so they repel other groups of casein, and thus the protein stays evenly distributed throughout the milk. When you add acid to milk, like vinegar or lemon juice, the negative charge on the groups of casein is neutralized. This means the protein groups no longer repel each other, and they start to clump together. The clumps thicken and sour the milk, and we get our buttermilk, which is what makes pancakes so delicious. Not only does it give them their tangy flavor, but the addition of an acid to a recipe that calls for baking soda, such as this one, prevents the formation of sodium carbonate by changing the way the baking soda reacts when heated. Sodium carbonate gives pancakes a bad taste and grainy texture. To make buttermilk at home, take 1 tablespoon of vinegar or lemon juice and add enough milk to make 1 cup. Let the milk and acid sit for 5 minutes, and voila! You have your homemade buttermilk. This recipe can be modified to make as much buttermilk as you need.
Today we are going to be talking about specific heat capacity. Specific heat capacity is the amount of heat energy it takes to heat up a substance by a certain temperature. We will be cooking our pancakes on a non-stick aluminum griddle cooktop. Aluminum has a relatively low specific heat capacity of 0.902 joules over grams degrees Celsius. This means that aluminum heats up very quickly and cools down very quickly. It doesn't hold on to heat energy for a very long time. Traditionally, pancakes were made in cast iron, which has a high specific heat capacity. This makes for a thick and heavy pancake. We're using aluminum today because we need to cook over a high heat for 1 to 2 minutes on each side. This allows for a perfect temp/heat energy going into the pancakes for a thin brown crust and a warm fluffy inside.
One scientific concept that is involved in the process of making pancakes is how heat energy is transferred to the stove to the pancake. Heat transfer is the process of heat energy traveling from one object to another. There are 3 types of heat transfer: conduction, which is the transfer of heat through physical touch; radiation, which is heat energy moving through air molecules; And the last form is convection, which is the transfer of heat in the form of a liquid or a gas. Heat is transferred to the pancakes through conduction. Depending on the type of stove, radiation can also be relevant. A gas stove will use radiation because there are flames that send heat energy to the pan and cause it to heat up. Electric stoves will use conduction because the heated stove is in direct contact with the pan. Pancakes were first invented in ancient Greece, although they had to be cooked over a fire because they didn't have stoves. Gas stoves were invented in the early 1800s before the electric stove because electricity was not necessary. Electric stoves were later invented in the early 1900s. Both gas and electric stoves will cook a pancake, although electric stoves will cook it more thoroughly. The pan is placed onto the heated stove and the pan becomes hotter. The pancake is then heated through physical touch from the heated pan.